Well, hi everyone, and thanks for coming. What I'd like to do now is start a sequence of lectures talking about another study design, what is known as the cohort study design, which is maybe the most basic of all the epidemiologic study designs that are used in practice. So let me first remind you of the roadmap, the different study designs that we're discussing in this series of lectures. First, we started off talking about more descriptive study designs. We talked about case reports for generating hypotheses that might be used for future studies. We talked about ecologic studies where we look at population-based information to see if there's a correlation and association on a population level between, say, a risk factor and some outcome. And then we talked about cross-sectional studies, photographs, snapshots of populations at one point in time, survey results, looking for associations between whether a person was a smoker or not and whether a person had been diagnosed with coronary heart disease or not. And then we moved on to something much more detailed, something that was specifically designed to address a research hypothesis. We then talked about experimental studies and linked them to the previous lectures I've given, and when we talked about trying to measure the causal effect of a risk factor on an outcome, and showed how experimental studies try to accomplish that goal. Well, today in this series of lectures, what I want to talk about is this next study design in this option of study designs, cohort studies. So just like what we did in experimental studies, let me start off by giving you the big picture of a cohort study design. Basically, what it involves is enrolling people who are at risk of developing some outcome. Let's suppose we want to know whether smokers have higher risk of developing heart disease than non-smokers. So what we do is we begin by enrolling a bunch of people who are at risk for developing heart disease. So they cannot be people who have been previously diagnosed with heart disease. They're no longer at risk for at least developing a first case of heart disease. So once we identify this at-risk population, and that's what the cohort is, a group of people, the next thing we will do is we will measure exposure on them. See who's the smokers and see who are the non-smokers. Then we follow those people over time, and at the end or during the follow-up time, we see who develops heart disease and who doesn't develop heart disease. So the four basic steps first are developing an at-risk population, classifying people as being, say, smokers or non-smokers, following people over time, and that's the distinguishing feature of the cohort study versus the case control study. The case control study had no follow-up. Cohort study is taking this group of people at risk and following them for the next 5, 10, 20 years, whatever the length of follow-up might be. And as we follow people, we record outcomes. So that's the basic big picture study design of a cohort study. Here's a diagram that shows that. What we're going to be doing is we start out with people at risk. Some people are exposed, those might be the smokers. Some people are non-exposed, those might be the non-smokers. We might plan to follow them for 20 years, so we follow those people over the next 20 years, and as we follow people, we observe who develops heart disease and who doesn't develop heart disease. So we epidemiologists, when we do cohort studies, are essentially the fly on the wall, just observing what's happening as the world passes in front of us. We observe these smokers and non-smokers at some point in time, and we just follow them for the next year, 5 years, 10 years, and see who gets heart disease and who doesn't get heart disease. That's the basic study design. It's an observational study. We're observing what happens to people. Now, as you looked at that slide, you might have had memories of some deja vu all over again. This looks familiar because, yes, in the last series of lectures, I showed this slide to describe the basic picture of an experimental study known as the randomized controlled trial. The randomized controlled trial took people who were at risk of developing some outcome. We might be comparing people who are being given a certain treatment versus a standard of care, seeing if the new treatment extends their lives. So we start out with people who are at risk for developing the outcome, at risk for dying. We randomize people to either take a new treatment or a standard of care treatment, and then we follow those people for the next 1 year, 5 years, 10 years to see who dies and who doesn't die. Same basic principle of a cohort study. And a randomized controlled trial is a special case of a cohort study. It enrolls people at risk of developing disease, classifies them as exposed, non-exposed, in this case, new treatment versus standard of care, follows them forwards in time, records outcomes. What's the distinguishing feature of the randomized trial that makes it a special type of a cohort study? It's the assignment, the randomization. So everything I talked about last time when I talked about randomized controlled trials was a prelude of what we'll be talking about now. I was talking about a special type of a cohort study where randomization was assigning treatment status. While in the general cohort study, it may well be the patient themselves who decides what treatment they have, more likely their physician, or in a population sense, it's the individual who decides to be a smoker or not to be a smoker. Well, here's another diagram that describes a basic cohort study design. I borrowed it from one of my colleagues, Heather Baer, who teaches a course here in the summer on introductory epidemiology. It just shows the results you might see if you did a study, a cohort study of 20 subjects, looking at the relationship between whether a patient was taking a statin or not, a drug, and whether that put them at increased risk or hopefully decreased risk for developing a hip fracture. So the exposure of interest is statin use, yes or no. The outcome is whether someone develops a hip fracture when they're followed over time. This is hypothetical data. Well, we had 20 people. Each person is going to be followed over time. So each of these lines in this diagram represents the follow-up of an individual. We have 10 people who are given statins. They're followed for a period of time. And one of them, the follow-up ends because that person has developed a hip fracture. We have another 10 people who are not taking statin. They're followed over time. And 2 of them do not develop hip fractures. So this picture describes what we might observe in this hypothetical study. The risk, the cumulative incidence of a hip fracture among the statin users would be 1 hip fracture out of 10 statin users. Among the non-statin users, we had 2 hip fractures out of 10 people. We can measure risk ratios by dividing the 10%, the 1 out of 10, by the 20%, the 2 out of 10, and said statin use cuts your risk in half for developing a hip fracture based on these data. That's the big picture of a cohort study. So let's imagine we're going to do a cohort study, and let's just go through some of the steps involved in that cohort study. Let's suppose you want to design a cohort study asking yourself the question, what's the effect of smoking on the risk of developing coronary heart disease? So what we want to do is measure the association between smoking, that's our exposure, and coronary heart disease, the incidence of coronary heart disease. That's going to be our outcome. So what we're envisioning is doing something like the Framingham Heart Study, something like the data you've been using in your various homework exercises here, and that I've been using as a template in the previous lectures I've been giving here. Let's imagine we enroll a bunch of smokers, we're going to enroll a bunch of non-smokers, we're going to follow them over time and measure the incidence of developing coronary heart disease in this particular situation. So here are some questions I want you to think about as we, in our minds, develop this cohort study. First of all, who do you want to enroll in this study? Let's suppose it's back in 1950. You're designing the Framingham Heart Study. Who do you want to be enrolled in your study? The fundamental principle that describes enrollment in a cohort study is that the people have to be at risk. And if you're talking about the risk of developing a first case of coronary heart disease, you do not want people in your study who already have heart disease. You want to exclude the people with prevalent heart disease. But then the question is, who do you want after that? Do you want to take a random sample of some general population? That's what Framingham tried to do. They tried to take typical people from a typical city in the United States. And they chose Framingham, Massachusetts, and they essentially tried to get a sample, a representative sample of the people living in Framingham. The nice feature of using a general population is that your results might be more what we call generalizable. You would hope that the association between smoking and heart disease that you see in this representative sample from Framingham, Massachusetts, would describe the association for any city that's typical like Framingham, Massachusetts. Well, The problem with taking a general population is you have to have enough people in your cohort study who have the exposure smoking and the non-exposure non-smoking. So if you take a general population, it might happen that if your exposure in general is rare, people tend not to have this exposure, that you might have lots of people in your cohort study, but very few people who are exposed. So sometimes, especially when you want to study a rare exposure, a general population might not be the best source to take a representative sample to enroll in your cohort study. It might be better to go out and find a group of people who are more likely to have that exposure, a higher prevalence of exposure. Well, that's an example of using something called a specific population. And one of the studies that I'm going to be talking about in this lecture is actually we're going to be bringing in the investigators of that study. They're going to be talking about what is known as the Nurses' Health Study. It's also a very well-known study, a cohort study, but instead of taking people from a general population, it took nurses from certain regions of our country. And what I want you to be thinking about, especially when we talk about this study later, what are the advantages or disadvantages of enrolling nurses in a study rather than general population? Hopefully, nurses are more health conscious. Hopefully, nurses are more likely to stay in the study and answer questions if we ask them about their risk factors and ask them about their outcomes. So by using a specific population, say nurses rather than the general population, we might have less potential for bias when we're trying to record information on those people, and maybe less potential for confounding, something we'll be talking about in this series of lectures. So that's the first question: who do you enroll? The next question you want to ask is, how are you going to measure the exposure? Say it's smoking. Do you measure it at baseline, classify people as smokers or non-smokers, and that's the only thing you're interested in, is whether on the first exam a person was a smoker or a person was a non-smoker. So for example, in your Framingham data set, our first exam is the 1956 exam, and we have a variable called cur-smoke1, which indicates whether you smoked or didn't smoke at that exam. And we could use that as our exposure to look at the incidence of developing heart disease in the next 24 years of follow-up. The problem is that that doesn't take into account the change in smoking status that a person might have. That a person who smokes in 1956 might stop smoking 4 years later and might start smoking again 10 years after that. So if we take a static representation of the exposure, smoking or non-smoking at one point in time, and that's all we bother to ask about in terms of the exposure status, we ignore the possibility that some of these smokers later are becoming non-smokers, and some of our non-smokers in 1956 later become smokers. So an alternative is to measure the exposure over time. In the Framingham study, everyone comes back 2 years to have their risk factor information updated. So we might have information at one exam that says this person's a smoker and another exam that says this person's a non-smoker. That means that person, when they're being followed over time, is contributing person years of observation to both the smoking person time and to the non-smoking person time. So for example, this is a simple diagram. Say in your data set you have a person for whom you have information at exam number 1, that was the 1956 exam, information at exam number 2, that was like 6 years later, and information at exam 3. Maybe at the first exam that person's value for smoking was, yes, I'm a smoker. At the second exam, he's a non-smoker. At the third exam, he might have started smoking again. So when you follow these people over time, between exam 1 and exam 2 for that person, you're observing person time that a smoker is contributing to your study. Between exam 2 and exam 3, you're seeing more person time that a non-smoker is contributing to your study. And finally, from exam 3 to the end of your study, if that person's smoking again, he's contributing smoking person time. So, depending how you want to measure the exposure, whether it's static at one point in time or time varying at this point in time, you're going to be able to answer different questions. The first question, if you measure as just a static representation of smoking, is asking, does your smoking status at 1956 influence your risk of developing heart disease in the next 24 years? On the other hand, if you're measuring continuously smoking at different points in time, you're going to be asking yourself, does the smoking status at a particular time during the follow-up influence the risk of developing the outcome around that time of follow-up? So there are different research questions that could be addressed by different ways of measuring the exposure.